All right, class, I wanted to go over some more truth table examples. I just finished recording the 11.1 through 11.3 videos, and I realized there were not as many truth table examples in there as I thought, and I knew you guys would want some more, so let's go through some more examples. Just a quick refresher, in case you skipped the other videos or it's been a few days, we join statements with logical connectives. And that's how we write compound statements. So we've got four right here, but there's two more. So we've got and, or, not, and if then. And those are represented with these symbols right here. When constructing a truth table, right, we have a simple statement P. And that simple statement is either going to have a truth value of true or false. Those are the only possible values. And we can list them in a table like so. First thing I want to talk about is not P. So not P is found because it has the opposite truth value of P. So if P is true, then not P is false. If P is false, then not P is true. For and is only true if both P and Q are true. So here we have P and Q are true, and that's the only time that P and Q are true. For or, I went backwards. For or, which is also called the disjunction, P or Q is true if either P is true, Q is true, or both P and Q are true. I.e., it's only false if both P and Q are false, right? So think about it as or, right? I need one or the other in order for it to be true. The exclusive or, denoted with this beautiful symbol right here, is read P or Q, but not both P and Q, okay? And this is only true when they have opposite truth values. So if P is true and Q is false, then P exclusive or Q is true. And if P is false and Q is true, then P exclusive or Q is true. They're only false if they have the same value, because it's P or Q, but not both of them. In this case, we have both of them. The conditional connective is also called if-then, right? This means if P, then Q. And P implies Q is only true if P is true and the conclusion Q is false. This is the only time it's true. True implies true is true, true implies false is false, false implies true is true, and false implies false is true. So let's practice by constructing some truth tables. So I have P and not Q. So I want to start this out by making a column for each of my simple statements. So I've got P and Q. Then I also need not Q and the whole compound statement P and not Q. So P has true, true, false, false. Okay, how did I know that it was going to be true, true, false, false? So here I have two simple statements. So I know that it has to be true for each value of Q and false for each value of Q. So I did two T's, two F's, and then TF, TF. I'll show you what that looks like with three. Keep in mind that because I have two, my sample space would have been 4. You can kind of think about it as if you flip a coin, right? If I flip a coin, my entire sample space would be heads, 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 tails, tails, heads, or tails, tails, right? This is the same, except now heads equal true and tails equal false, right? We have a sample space of 4. That might have made things more complicated than I needed to, I'm sorry. But it was one way to think about how I know my truth values to fill in through this table for P and Q. So next I have not Q. Well, that's the opposite of Q. So in our first row, Q is true. so not Q is false. In my second row, Q is false, so not Q is true. My third row, Q is false, so not Q is false. And in my fourth row, Q is false, so not Q is true. Now, I want to know P and not Q. It's important to remember that for the and symbol, it's only true if both P and not Q are true. So here I have P and Q, not Q. So true and false gives me a false. True and true gives me a true. False and false gives me false, right? Because I need them both to be true. And false and true gives me false. So here we've constructed our truth table for P and not Q. And there you have it. So you can check your answers if you didn't watch the video. Next, I want to know not P exclusive or Q. So remember, exclusive or Q is only true when they both don't have the same truth value. So let's go ahead and make my table. I know I'm going to need a P, a Q, a not P, and then my whole compound statement. So I fill in true, true, false, false, true, false, true, false. Not P is going to be false, not P is false, not P is true, not P is true. Now, I'm looking at these two columns right here to figure out not P exclusive or Q. And remember, this is only true, okay, when both of them don't have the same value. So here I have true and false. That's true, because remember, exclusive or means one or the other, but not both. False and false, that's going to be false, right? Because they both have the same value. True and true, same thing, false. And false and true, same thing, true.